大概先生。
Wait, okay. Well, should I wait like if okay, I feel like no one else is gonna join. I'll just start. All right, we're back for geometry for another lesson. We'll just go over a quick review of similar triangles and congruent triangles because it's been a long time. So we'll just like quickly review it again before we go into questions. So congruent triangles, the three conditions, if you guys remember, side, 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 angle, angle, side, and side, angle, side. Also have to remember, the side angle side, the angle has to be in between the two sides. Does everyone remember that? And then that means that the triangles will have like the same angles and then the exact same side. So they're like the exact same size and shape, basically. Yeah. And then for similar triangles, they're triangles with like the same shape but like different size. So then the three conditions are side, 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 where it's ratios this time, not like the sides are the exact same. And then all three of the angles are the same. And then side, angle, side again, but this time it's the ratios. So I hope everyone remembers that. So we'll just move on to doing more questions, I guess. So here's a question for everyone to try. All right. So does anyone have like any ideas or anything right now on how to like approach the question? No? All right. I'll try help you guys out, I guess. Wait, let me just put this on the Jamboard. So we're trying to find HC over JE, right? So with these ratio questions, you're normally to find ratios, you're normally always looking for similar triangles because that's the only way to kind of get information about ratios. So we're trying to find the ratio between HC and JE, right? So then the first thing you want to look for is like what triangles is like HC a part of and what triangles are JE a part of, and then try find some like similar triangles between those triangles if you kind of get what I'm saying. All right, I'll just go through a little bit more of the question, right? So we know we want to find similar like triangles with like sides HC or JE, right? So we know, I guess, the only triangles we can really see they're part of is like HC is this triangle over here, and this triangle over here, and then JE is only like this triangle and like this triangle over here. So we kind of want to find like triangles that are similar to like HCD or GHC or JEF or GJE. Yeah, so we're trying to find like some triangles similar to these so we can maybe get some information about their ratios, you know what I'm saying? So yeah. All right, does anyone have like any ideas so far, or should I just like go through the problem now? Or do you guys want like a little bit more time? Um, uh, HCD and JEF have one side and one angle the same. That's not necessarily true. We don't know that. Oh, we do know that one angle is the same though, because we know because these three sides are parallel, right? So then we know this angle. Oh, wait, they have two same sides. That's right. This one, this one. Yeah, you're right. But what does that tell us though? ABC. Yeah, that's true. You're right. I forgot. Okay, does anyone want me to like just go through this question now? Do you guys want more time to like think about it? All right, so we're given that HC is parallel to JE is parallel to like GA, right? So they've given us that it's parallel to GA for some reason. So we want to try use GA. And then you might notice like if you look at triangle GAD, you might, and so I'll just draw it out without like all these lines. It might make it easier to see, right? So then if I have GAD here, I guess the diagram has a lot of lines on it, so it might be a bit hard to see. But if I have my triangle GAD here, and I have my point C, and I draw this parallel line up such that these two lines are parallel. So this is H. What can you guys tell me about this diagram? Yeah, so GAD and HCD are similar because so these two lines are parallel. So then we have like all the angles are equal. So this angle is this equal to this angle is equal to this angle, and then that angle shared. So these triangles are similar. So we can find ratios. Um, so we can like relate like um yeah, we can find ratios basically. So we can do HC over GA equals CD over AD, right? But we know that CD is equal to 1, and we know AD equals 3, right? Because it's given in the question because these are all 1. So now we know that HC over GA is equal to 1 over 3. And we can do something similar with triangle JEF. So if I kind of do the same thing, like if I just like redraw this diagram without all the lines. So I basically just only include J and E, such that these two lines are parallel. You can see that triangle JE, or wait, this was not D. Oh, yeah, this is D. Yeah, this is F. So you can see that JEF is similar to GAF. So you can do something similar. So you can use the similar, so we can find ratios again. So we know JE over GA equals EF over AF, right? And again, we know that EF equals 1, and then we know AF is 5. So now we know that GA from like this from the previous one, we know that GA equals HC over 3. And then from this one over here, we know GA. Oh, wait, this is not right. HC times 3. And then from this one over here, we know that GA equals 5 times G. So then if you divide one equation by the other equation, you get 1 equals 3 over 5. HC over GE over JE. So then we know that HC over JE equals 5 over 3. Does everyone kind of understand that? Did everyone follow along? Yeah? Yeah, so then I guess the main, motivation for this question is like seeing this condition they gave us. So I guess we're trying to look for similar triangles using HC, JE, and GA. And then once you find everything in terms of GA, then you can just divide to find the ratio if you kind of understand. Yeah. Is everyone all good with that? Or do you guys want like a bit more time to just like uh think about the question and like digest it? Or should we just move on straight away? Okay, I'm gonna assume everyone fully understood that, so I'm just gonna move on to the next question. So we have this question, which is a little bit tricky.
Okay, so does anyone have any questions? Oh no, does anyone have any ideas? Josie said, what does that mean? A N and B C and C D and D. Yeah. Oh yeah, because it's a square, so all the sides are equal. Oh yeah, A B, yeah. So A B B C C D A D are all one length. Okay, I'll give you 15 more seconds and just if you have the answer, just type it in the chat. Okay, so Amanat said is AE equal to 2 square root 2? Um, yes, so Ethan, can you just load up the Jamboard? Okay, so can you guys see this? Okay, so let me just draw the lengths of AD and CD. So AD and CD are 1 because it's a square. And from Pythagoras, we know that AC is 1 squared plus 1 squared, right? And root that. So it'll be 1 plus 1. So AC will just be root 2. And then, like Amarat said, since AC is equal to CE, which the question tells us, um, AE is 2 root 2. Okay, so hopefully this would, give you some hints. Oh, wait, Tronzin saying that. Did the question say that the area of the square is 1? So if the area of the square is 1, so the area of the square is given by the product of its lengths, right? So if this is x, let's say, then the area would be x squared. So if the area is 1, then x squared would be equal to 1. So that means the length is 1. So if the square has area 1, then the length will be 1. So that's how we got AD is equal to 1. I'll give you guys a hint. You can use similar triangles for this question. So try to find similar triangles. Might be like not immediately obvious, so you might have to draw, additional lines. So BE is 2 square root 2 minus 1. Or what's BE? Okay, do you guys want me to go through the answer or do you guys want more time? Um, I'll just go through the answer then. Okay. So I'll give you guys another hint. You could perhaps draw, you could perhaps extend AB, then extend this line here and create a point P. So this is an imaginary point that I have just created. And let's say that PE is the vertical line going through PB that is perpendicular to PB. So could you guys see any similar triangles in the diagram now? Just drop it in chat or like something. Okay, I'll just go through it because since triangles ABC and APE, since they're both right angle triangles, and we know that the ratios are the same because AC is equal to CE, so that means the area of APE must be 4 times the area of ABC. So if ABC is similar to APE, then we know that the ratio of PE to AP. Oh wait, EA is equal to the ratio of BC to AC. And from before we know that we know 3 of these lengths already. So we can basically just solve for PE using ratios. So I'll just type it out because my handwriting's a bit goofy. So we know, see that PE equals BC over AD times EA. You guys see this? Okay, so, and we know that BC is 1 because it's a square. AD is also 1. And then EA is 2 root 2, which is what Amarat found earlier. Okay, so if we solve, so that P would be equal to 2 root 2, right? Okay. You can also find PB. So we know that PA must be equal to 2. Since PEA and BCA are similar, we know that AC is equal to C. That means PB and BA must be equal. So, oh, wait, yeah, PA equals 2. So that means PB must be equal to 1. And so using Pythagoras, so if you look at, I'll use a different color. And so we know that this is 1, and that this is wait, hold up. Oh wait, I think I messed up. Let me just fix this. Okay, PE should be equal to 2. I used the wrong ratios, my bad. Okay. Oh, so PE must be PE must be equal to 2. So from Pythagoras we know that PE must be 1 squared plus 2 squared, so be root 5. Okay, we'll just move on to the next question. Okay, so just take, I guess, like 5 minutes to do this question, and we'll drop some hints for you guys.
All right, so I'll just walk through the beginning of the problem for you guys. So we have that triangle PAB is similar to triangle PCA, right? So this means that with our angle conditions that we have PA over PC equals PB over PA equals AB over AC, right? Because when we write out our like similar triangle notation, we have to write in like a specific order so that like this side has to correspond to this side and like this side has to correspond to this side and so on. So we know that actually I'll just let you guys think about it a bit more from here, I guess.
Yo, if you guys have any questions, just ask in the chat. Because we want more audience participation.
All right, if you have like any ideas, just like say it in the chat or like to like I guess it helps to like put out your ideas so everyone can like think about it and maybe get somewhere with it. Or if you guys have no ideas, just tell me. I guess we can keep going with the question. Does anyone have like any ideas, any progress they've made that they'd like to share, or should I just like keep going with the question? All right, so we're given that AB equals 8, right? And then AC equals 7. So then we know that PA over PC equals 8 over 7, right? So we've used these two parts And we can also use, I guess the main observation you want to make here is that this long side PB is actually equal to PC plus 7. I don't know if this actually, maybe thinking about this even now, I've given you that PB equals PC plus 7. Maybe keep trying the question, I guess. See if you guys can come up with any more ideas. Because we have this PB over here, this PB over here. So we can replace this PB with PC plus 7. So we basically have everything in terms of like PA and PC. Maybe I'll put everything on a new slide just to make everything clearer. So we have like PA over P7 equals 8 over 7. And then we have PB over PA equals 8 over 7. We have PB equals PC plus 7. We want to find, like, this is the information we've gathered from the diagram. So it kind of becomes like an algebra question now. A PC. Yeah, so I think Josie's got it. So basically we can kind of sub this for this. So we get PC plus 7 over PA. PA equals 8 over 7, right? And we can split this into two fractions. So this is equal to, let me around the right hand side. PC over PA plus 7 over PA, right? Well, that's a very good A. But then we know that PC over PA is equal to 7 over 8 from this. So we can like flip this around. So we get PC over PA equals 7 over 8, right? So we can sub this into this. So then we get 8 over 7 equals 7 over 8 plus 7 over PA. And then maybe I'll let you guys finish off the solution, I guess. Actually, maybe not. This is just algebra. You just do some rearranging. So you just, I guess, multiply. Or I guess we move this fraction to the left-hand side. So we get 8 over 7 minus 7 over 8 equals 7 over PA. And then 8 over 7 minus 7 over PA, I think is, what is this? 64 minus 49. 15 over 56. And then you do the cross multiplication to get 15 PA equals 7 times 56 and then over 15. So then you can use this to find PC if you just sub this back in there. Does that kind of make sense? Did everyone follow that, or should I like go through it again? Did everyone follow? Was there some people confused? I mean, if I go from the start of the question, right? So we're given that this is true, right? And then like the only way we could possibly use this information is using ratios, because if you just try find the angles, right? Because they're similar. So let's say PAB is similar to PCA. So that means like this angle equals this angle, and then this angle equals this angle. That doesn't really like tell us anything, I guess. I mean, if you look at this, you don't get a lot of information, and they've already given you a bunch of sides. So like, is the only way to realistically make progress on this question is just by using ratios. So then you just list out all the ratios, and then you. I guess the hard part of the question would be noticing that PB equals PC plus 7, because I guess one way to think about it is because you've given that this ratio is like given this ratio. So you have like one equation with PA and PC in it. And then I guess if you want to find both of them, you'd want to find like another equation to do a simultaneous equation. And I guess the only way to find that equation would be looking at like this term and seeing what you can do with it. So I guess this is like the hard part of the question, like this observation. And then after that, it just becomes algebra. So does that kind of make a little bit more sense, I guess? Should we move on to the next question? PAC and ACB. Not necessarily. We don't actually know that because they would only be similar if, like, for example, let me just change this color. If, for example, like this angle were to equal this angle, and then like this angle equals this angle, or it looks like this, which is not necessarily true. So like we don't actually know that, I guess. It's like not necessarily true. We've only been given that PAB is similar to PCA. Why is angle A and angle C the same then? Also, we've been given like this condition. And so when we write it out, we have to write it out in a specific order such that when you like kind of like read the expression, like each angle has to be the same. So like this is like kind of like notation based. So when you read out PAB and PCA, you have to write it such that like this means that like PAB has to equal angle PCA. So yeah. So and then if you read it this way, so you start off with the P, the B, and the A, you have to do the same thing here. So PAC. So then you get angle PBA equals angle PAC. So that's how we got all the angle conditions. Wait, yeah, but it's the other side of the angle. Why is angle A and angle C the same? Wait, what do you mean the other side? PAB equals PCA. PAB equals PCA. Oh, whoops. I did the wrong angle. That's so true. It's this one. Okay, yeah. Okay, it didn't actually matter because we were only working with ratios, but that's my bad. I'm sorry. I guess I'll do a quick review of similar triangles because I think there's a little bit of confusion. So when we say that, for example, like let's say triangle ABC is, I guess, similar to triangle like XYZ, right? What this means is that AB over XY equals BC over YZ equals AC over XZ, right? So if you kind of look at it like this, if you kind of read it like this, so the first two letters of the first one will always correspond with the first two letters of this one. Then like the last two letters of this one will correspond with the last two letters of this one, and then so on and so then AC, it's like AC over XZ equals AB over XY equals BC over YZ. Is that what you guys are confused about? Because then if I'd like draw it out, I guess. ABC. Because there's like a specific order you have to write this in. Z. Triangle ABC side side side. Wait, no, this is just an example. This is just an example. This is just to like understand the ratios of similar triangles. Like if I have like ABC is similar to XYZ, then these ratios must be true. Like I'm saying like if. Does anyone like understand similar triangles in general? Or does anyone have any problems with this previous question? Ratios must be true by side, side, side. Yeah, that's just how similar triangles work. Yeah, they have to be true. Does anyone have any other questions about similar triangles in general, or just like the previous question? Yeah. If no one has any questions about this specific question, then we'll move on to the next question. Yeah, this is not a straightforward question, but maybe I'll just like go through this one with you guys instead of giving you guys some time to think. Maybe that'll be more helpful. Maybe just take a minute to just like think about this. Again, since we're trying to find lengths, you want to find some ratios. So you want to look for similar triangles. So I guess the first task I'll give you guys is to look at this question and just try find some pairs of similar triangles. That should be like your sub goal. Just try find some like pairs of similar triangles. Like forget the side lengths for a second. Just find some similar triangles basically. Yeah. All right, so you guys know how there's three ways to show that there are similar triangles, right? So you have side side side, and you have angle angle, and you have side angle side. So when we're trying to find similar triangles in this question, like which one do you think we should be trying to use? And like, because there's a specific one we want to try use because there's a lack of information for the other one. So which one do you think it is? Like, should we, when we're looking for similar triangles in this question, should we be trying to prove that like angles are the same, or should we try to be finding some ratios if you kind of get what the question's asking? Like, what do you guys think? Just looking at this question. Is EC equal to 1? Yes, EC is equal to 1, but let's just forget about that for a second. Let's just focus only on trying to find similar triangles. Like, how would we like try find similar triangles? Are we gonna try use angle angle, side angle side, or like side side side? Like, which method do you think would be the best in this case? because if you were to look at this question, right, there's a lot of like angles we've been given. We've been given this angle, this angle, this angle, this angle, and we can use this to find other angles as well. So, for example, because a triangle has the sum of the three angles has to be 180 degrees, we can technically also find this angle. We can also find this angle, and then we can also find this angle, this angle, and this angle. So we can basically find every single angle in the diagram. So we want to be trying to find similar triangles by proving like angle, if you guys know what I'm saying, because we're not given much ratios, but we're given a lot of angles. So we want to try find similar triangles, specifically using angles. So I hope that helps like with trying to find some similar triangles. Maybe I'll help you guys by just uh giving you all the angles in this question. Maybe that help you guys a little bit. So, firstly, if we just consider the big triangle, right? We've already been given two of the angles, correct? So let's just try find the third angle. So this angle here would be 180 minus 3 theta minus theta, right? Which is 180 minus 4 theta. Okay. And then we also know we can also find like this angle right here. So this is 180 minus theta, like minus 2 theta, which means that this angle here is 2 theta, which means this angle here is 180 degrees minus 3 theta. And then which means that like this angle over here is 3 theta. All right, now can you guys find some like triangles with the exact same angles now if you just look at it? There's a lot of triangles to consider, but there are some triangles here that are similar with the exact same angles. Does anyone have any ideas? Um, BDE equals DCB. Yeah, so well they're not equal, they're like similar. So but I think you're on the right track. So this triangle right here is similar to this triangle. This so the small triangle inside of is similar to the big triangle, yeah. So if I were to just like make it a little bit more clear, I'll just draw on the side for you guys to see. You can see that this angle is theta, this angle is theta, and then this angle is 2 theta, and this angle is theta. So then you can see that this angle here is equal to this angle, this big angle here. And you also see that this small angle here is equal to this one here. So that means that this triangle here is similar to this big triangle. So that is one of the similar triangles in the question. So I'll just write it out on the screen for you guys. BDE. Triangle BDE is similar to triangle. Is this right? DCB. It's all the way around. Triangle ADB and triangle ABC are also similar. Yeah, so that's the second pair of similar triangles. So then if you take a look, this triangle right here is also similar to the big triangle ABC. So if I draw it out a little bit more clearly, because the diagram's a bit cluttered. So we have this, right? So then we have this angle here is 3 theta. And then this angle here is 3 theta. And then this angle here is theta, and then this angle here is theta. So then we have this angle equals this angle, and then this small angle equals this small angle. So then these two triangles are also similar. So we have, I guess, wait, A, B, B, C is similar to the triangle. It's like ADB, maybe. Yeah, so then I'll just tell you guys right here. I think these are the only two similar triangles you need. So you can stop looking for similar triangles now and then try do some ratio chasing. So yeah, just list out the ratios and have a play around with the ratios, I guess. AB over AC does equal 4 over 5, yes. Maybe I just, if you guys have copied these similar triangles down, I'll just move on to a new slide so you guys can maybe, yeah, maybe see this a bit better, I guess. Actually, I'll just copy down the triangles here. It's like BDE, similar to triangle CDB, and then ABC, ADB. Wait, what are you asking? So can triangle CAB be written as triangle BDC? What do you mean like written as? As in like they're the exact same? Because we write the triangles, it doesn't really matter what order we write this, like the letters in. So for example, over here, I can reverse the letters if I want to. I can say CBA is similar to triangle BDA. But as long as the ratios are consistent, so for example, like CB has to always correspond with BD and like BA has to always correspond with AD. So it doesn't really matter how you write the triangles. So does anyone have any like ratios that managed to figure out? Does anyone got any ratios? I'll just quickly. I mean, if I go here and I just can look at this ratio first. I guess we can focus on this triangle. So we know AB over AD equals AC over AB equals BC over BD, right? So then we're given that AB equals 4. So 4 over 8. Have we been given AD? We have not been given AD. So 4 over AD equals AC over AB. We've been given AC, which is 5. And then we've been given AB, which is 4. And then BC and BD. We do not know what BC is. That was trying to find. And we do not know what BD is as well. Yeah. So this is what we get when we write this out. So you can notice that AD, you can find AD basically. Wouldn't AD be 4? Wait, wouldn't AD be 4? AD is not necessarily 4. Wait, where did you get AD equals 4 from? Not AD. Yeah, AE is 4, you're right. AE is 4. So then since we know AE is 4, that means EC would be 1. Yeah. But we can from this we get that AD equals 16 over 5. Yeah. That is something we get from those ratios. Now I guess you want to try look at this pair of similar triangles and see what you get from those ratios. So just have a go at like listing out these ratios and just plug in the information you know and just see what happens. All right, so has anyone like tried to like have a play around with the ratios for this pair of triangles? Has anyone gotten anything with this? Or I don't know if anyone's actually like made any progress, so I'll just take this ratio into consideration. Or maybe I'll just start this on a new page. Wait, so okay, I'll write a bit smaller actually. BDE was it? This is similar to triangle CDB. So the ratios we get from this one are BD over CD equals BE over CB equals DE over BD, right? Did everyone get this? Okay, first thing you want to notice is that this is what we're trying to look for, right? BC, right? So second thing I guess you could notice is that if you look at BD over CD and then you look at wait. Oh yeah, this is what we're trying to okay. I forgot that we need to make like a synthetic observation first. So if we go back to this diagram, because you notice we like basically don't know any of the sides in this. So I'll just like rub off all these angles. So we know that this angle here is 2 theta, right? This angle right here. So that means ABE is an isosceles triangle, right? So that means I guess this side length right here is 4, which means this side length here is 1. But then this triangle here is an isosceles triangle, right? So that means BE equals 1 as well. So yeah. So if we go back here, we can do some substituting. I'll just rub this out actually. Yeah. All right, I'll give you a bit more time to think about this, I guess. All right. Is anyone like a bit stuck? Should I like keep going? I'll just write out the additional information we know. This will be useful. So how's everyone faring, I guess? Do you want me to like keep going with the question? So I guess if you come back to this diagram, so we see here that we don't know actually like we haven't been given any of these sides, for example. So we don't know BD and we don't know CD and we don't know DE. And this is what we're trying to find, right? So then if you come back to this diagram though, you'll notice that we can actually find CD and DE because if you look here, right, we know that AD, well, from our previous ratio, like over here, we found that AD is equal to 16 over 5, right? Oh. So then we know that like this side length here is 16 over 5. So we can actually, if we just consider this line as a whole, you can actually find everything we want except BD. So you can find CD and you can find DE because we have basically we have a line segment, right? We have A, and then we have D, then we have E, and then we have C, right? So we're given this entire thing is 5. So this entire thing is 5, and we know that AD is 16 over 5. And we know that CE equals 1, and we know that AE equals 4. So you can actually find DE and CD. So try finish off the question from here. Like calculate CD and DE and then solve to find BC, I guess. And then someone tell me the answer because I actually don't know what the answer is. Is everyone following, I guess? Does everyone understand that or do you want me to like go over it again? Are we all good? I'm assuming since no one is saying everything, everyone perfectly understood everything I said. Okay, I'm assuming everyone perfectly understood. I'll just give you like a general overview of the solution without the numbers because I don't want to like calculate everything. But we can basically calculate CD and DE, right? From like this thing over here. So we know that like CD equals well we'll first calculate DE since we know that DE equals 4 minus 16 over 5, right? So that's this line here, DE. And then whatever DE is, you add 1 to find CD. So we can basically find CD and DE. And then we know from like these two terms, we know that BD squared equals CD times DE. And since we know that what CD and DE are, we can actually find BD. And since we know all of these numbers here, we can now find BC. So that's basically the general overview of the solution. I don't know what the actual numbers are, but I don't think the numbers matter here. It's just the more the method that matters. So basically, yeah, that's how you do this question. Does anyone have any questions? That was quite a difficult question. So if you guys want me to like go over some steps again, then just ask. It's fine. Did everyone fully understand that? Like if you guys have any questions, just say so. And if you don't have any questions, just say that you don't have any questions, so I know when to move on. I mean, let me just look at this from the start again. So you guys got the similar triangles part, right? I think maybe the difficulty here comes in just because I feel like the identifying the similar triangles part is maybe not the problem for you guys here. I think it's maybe once you get the similar triangles, it's quite hard to like do the ratio chasing, I guess. So you guys found the similar triangles, but then you guys can use the ratios that you found from the similar triangles to actually finish off the question, I guess. I mean, it's quite hard because we can use this one to find AD by just direct substitution. So I hope everyone could get this part because once you have this pair of similar triangles, you just list out the ratio that we get and we just substitute the values that we have to find AD. So does anyone have any problems with this part so far? Because you found the similar triangles and you basically just list out all the ratios and then sub in to see what you get and you get that AD equals 16 over 5. Does anyone have any problems up to that stage? Because if not, Because once you've done that, you'll notice that we can't really get anything out of this ratio anymore because we don't know BC, we don't know BD, and we managed to extract a piece of information. So we move on to the other pair of similar triangles, and we basically get this ratio. I guess the problem with this part was that we had to make quite a few like synthetic observations in the diagram. So you'll notice that when we actually wrote this diagram out, we were not given any of the silence. We had to actually calculate them ourselves. But I guess when you look at this ratio, because I'm not sure what you guys were thinking when you guys were doing this question, because like you guys didn't say anything, but like I'm assuming what happened is you guys looked at this ratio and didn't know any of the silence and got stuck. I guess you just have to go back to the diagram and just like ask yourself, like, we were not given these sidelets, but can we actually like find these sidelets from the diagram and just have to think about it? Because you could have asked yourself, like, okay, what is, for example, is there a way I can calculate DE? Is there a way I can, calculate CD and then just go from there? I guess the hardest part of this question, okay, I don't know what the hardest part of this question was because you guys aren't saying anything. I was like, what part of this question do you guys think was difficult? Like, where was the steps you guys got stuck? Yo, is anyone even listening to me? This is so sad. All right, okay. No one is saying anything. So I'm assuming everyone fully understood everything, and we're just going to move on. Okay, we're starting circles, I guess. All right, William, do you want to talk about circles or should I talk about circles?
Yo, guys, moving on to circles now. So we only have 15 minutes left in this lesson, so we'll probably cover, well, so like today's going to be a brief intro to circles. We'll build on that next week. I mean, next lesson. Okay, so here's some theorem. This is a definition of a circle. So a circle is the locus of points in a plane with an equal distance from a fixed point. And you guys probably know this. So the fixed point is called the center, and the distance from the center to a point on the circle is called the radius. So basically, all of these, so if you look at the diagram here, if you pick any points on the purple line, it's always going to be the same distance from the black dot, which is the center. And as you can see here, there's a few terms that you should know. So a chord is when you basically just slice through circle, and then the diameter is double the radius, so that's when you slice through the circle at the center. And then the tangent is a line that touches the circle at one point. And you guys probably know this, so the area is pi r squared and the circumference is given by 2 pi r. So just know these because you will need to know these for future questions. Here are some basic properties of circles. So you guys probably know this. I'm just going to review these. So in a semicircle, if you draw a triangle with the right angle points at the touching the edge of the circle, then it always forms a 90-degree angle. And the second theorem is the angle at the circumference subtended at the center is double the angle when it's on the circle. Then the next theorem.
Does everyone actually know like why these theorems are true, by the way? Or like, does anyone know how to like actually prove these theorems by any chance? Like, or have you
You guys
guys?
should try proving it.
Wait, we'll just go. Okay, maybe this is an easy exercise for everyone.
Yeah.
Um, okay, so yo, yeah, so we'll just go through the first one, I guess. So we have the diameter of the circle, and which pick any random point on the circle and make a triangle, and this will always be a right angle. Yeah, so does anyone know how to actually like why this is true? And if you don't know why this is true, maybe you should try I guess proving this yourself. You guys gonna like please say something? When I ask a question, can someone please answer? I beg of you guys. Does anyone actually know like why? Or do I need to explain why? Or is everyone AFK? Should we just end the meeting right now? Someone finally replied to me. Oh my god, this is beautiful. Okay, so we don't know this is 90 degrees first, right? So then, okay, let's get rid of this line, right? So we have the center of the circle here, right? And then we can take this random point that we chose on the circle and actually connect this line to the center. And so since the circle, all the points on the circle are the same distance from the radius, right? So we know that all three of these sides are equal, right? So we basically get two isosceles triangles. So for example, let's say that this angle is angle A, right? Then this angle must also be angle A because it's an isosceles triangle, correct? So we have this isosceles triangle here. And let's say we have, like, let's say this angle is B, right? Therefore, this angle here is angle B as well because it's an isosceles triangle, right? But then we also know that the sum of the angles in this big triangle has to be 180 degrees, right? So when we calculate the angle sum of the angles inside the big triangle, we get 2a plus 2b, right? And we know that this has to equal 180 degrees. So then we therefore know that a plus b is always equal to 90 degrees, which is just this angle right here. So that means that this angle here will always be a 90-degree angle. Does everyone understand? Does it make sense why there's always a 90-degree angle? Yep. For the next one, right? So for the circle subtended by this, so we have, I guess, a random point on the circle here, and we have the angle at the center here, right? And we want to show that this angle here is exactly half of this angle. So how are we going to do this one? We're going to do something similar to the last proof I just showed you. We're going to take this point here and we're going to connect it to the center again. So it's like circles, like the only property circles have is that all the distances the points have to the center of the circle are the exact same. So we're going to try to exploit this property as much as possible. So again, we get a lot of isosceles triangles. So we know that this side equals this side equals this side, right? So we get that. Okay, so we had, let's say this angle is angle like A, for example, right? And this angle also is angle A. And this angle is like angle B. And this angle is also angle B. So we also know that this angle here, C, these two angles are equal to each other. So then again, we can use the angle sum of the triangle. So we know that 2a plus 2b plus 2c equals 180, right? So if I move this 2c to the other side, we get 2a plus 2b equals 180 minus 2c. But you'll also notice that this angle right here, because like this triangle here is an isosceles triangle. So therefore this angle here would be 180 minus 2c, right? But we've shown that 180 minus 2c is actually equal to 2a plus 2b. So I can just like get rid of this. So then this angle here becomes 2a plus 2b, which is exactly double of this angle. Yeah. I guess there's a neater way to show this with less calculation. There's a nice way to do this. So what you actually do is you take your line that you drew to the center and you keep extending it down like this. So this is a straight line that we've just drawn here, right? So then this angle here is the exterior of this isosceles triangle right here. And so this angle here is 2a. And then this angle here is the exterior of the other isosceles triangle. So this angle here is the sum of this angle plus this angle. So this angle here is 2b. That's also a really nice way to show that the angle at the center is always double the angle at the circumference. So I hope everyone understood that. I guess we'll move on to some more theorems, I guess. Okay, keep going.
Okay, guys, you probably know this already. So, the angle between a radius and a tangent is 90 degrees. So the tangent only touches the circle at one point. And the other theorem is alternate segment theorem. So the angle between the chord and the tangent is equal to opposite angle inside the triangle. So if you look at the diagram here, the green angles are equal and the blue ones are equal to. And
Wait, we have to prove y again.
okay, I'm so sorry.
What? Oh, we have 5 minutes left. Actually, maybe we should just go through all the theorems and we'll just prove them next time. All right, just keep going. Never mind.
Okay. So moving on. So the tangents to a circle from the same point will be equal length. So point C is outside the circle and CD is equal to CE. And the last one is the radius through the midpoint of a chord will bisect the chord at 90 degrees. So moving on is here's a warm-up question. We only have 4 minutes, so
Actually,
probably just do this next week. I mean next lesson.
maybe we should just stop here.
Okay, thank you boys for coming to this tutorial. Hope you learned something.
Wait, guys, does anyone have any feedback on this tutorial? Because no one was really talking, honestly.
Can we have more audience participation, please, so that we know that what's going on like in your heads and stuff. And we like to see creative thinking in our students. That's why we are promoting Mind and Z. So please guys just talk more in the chats.
Yeah.
Thank you, Alicia.
Okay, maybe it's our fault for giving a little bit harder questions. I guess we'll try build it up a little bit more next time. Maybe we'll spend a bit more time on circles than we did on similar triangles.
Yeah.
So yeah. But next time when we're doing a question, like try like when you make some progress on a question or you have any questions or like asking what direction you should go to, like following each step, you should put your ideas in the chat so everyone can take a look at it. And this can actually help everyone else. And it also helps me like figure out where everyone is and like how they are like doing on the question. And like after we do a question, if you guys have any like problems with the steps, you can also say as well, and I can repeat and go through the question for you. It's completely fine. I don't mind doing that. And yeah, you also just give feedback, you know. Does anyone have any other questions, I guess?
If you have no more questions, you can leave.
Maybe I'll put our contact details up again in case everyone forgot from
Yeah.
last week. That's William's email if you have any questions. And then this one's my email. Wait. This one is my email. Yeah, if you have any questions, you can email one of us. All right, if you have no more questions, I suppose you can leave now.